السلام علیکم. آج سافٹ ویئر کوالٹی ایشورنس کا 26 لیکچر ہے. پچھلے لیکچر میں ہم سافٹ ویئر ٹیسٹنگ کی بات کر رہے تھے اور اسپیسیفکلی ہم بلیک باکس ٹیسٹنگ اور وائٹ باکس ٹیسٹنگ کی بات کر رہے تھے. پچھلے لیکچر میں ہم نے انٹروڈکشن لیا تھا کہ بلیک باکس ٹیسٹنگ کیا ہوتی ہے، وائٹ باکس ٹیسٹنگ کیا ہوتی ہے، اور تھوڑا سا ہم نے ان کے کمپیریزن بھی کیا تھا. ہم نے کمپیریزن کیا تھا ان کا پرسپیکٹو سے، ہم نے کمپیریزن کیا تھا ان کے آبجیکٹس کے لحاظ سے کہ کن آبجیکٹس کے اوپر بلیک باکس ٹیسٹنگ ہوتی ہے اور کن پہ وائٹ باکس ٹیسٹنگ ہوتی ہے. پھر ہم نے ٹائم لائن کی بات کی تھی کہ جو وائٹ باکس ٹیسٹنگ ہے وہ یوزلی بلیک باکس ٹیسٹنگ سے پہلے ہوتی ہے، تو ٹائم لائن کے لحاظ سے یہ پہلے ہونے والی ایکٹیویٹی ہے. پھر ہم نے ڈیفیکٹ فوکس کی بات کی تھی. پھر ہم نے ڈیفیکٹ ڈیٹیکشن اینڈ فکسنگ کی جو ایکٹیویٹیز ہیں ان کی بات کی تھی دونوں ٹیکنیکس کے حوالے سے. اور پھر ہم نے بات کی تھی کہ ان دونوں ٹیکنیکس میں کون سے ٹیسٹرز یوز آتے ہیں. مثلا وائٹ باکس ٹیسٹنگ یوزلی جو ہے وہ پروگرامرز خود کرتے ہیں، جبکہ بلیک باکس ٹیسٹنگ جو ہے وہ انڈیپینڈنٹ ٹیسٹنگ کرتے ہیں یا ٹیسٹ گروپ کرتے ہیں. اور بعض سچویشنز میں جہاں کرٹیکل پروجیکٹس ہوتے ہیں وہاں ہم انڈیپینڈنٹ ویریفیکیشن اینڈ ویلیڈیشن گروپ یا IVNV گروپ کو، جو کہ تھرڈ پارٹی ٹیسٹرز ہیں، ان کو بھی یوز کرتے ہیں. اینڈ سو ڈپینڈنگ آن دا نیچر آف دا پروجیکٹ، دی امپورٹنس آف ٹیسٹنگ اینڈ کریٹیکلٹی آف دی project, we employ different testing groups to perform these testing activities. تو یہ تو وہ ڈسکشن تھی جو ہم نے پچھلے لیکچر میں کی تھی. آج ہم اسپیسیفکلی وائٹ باکس ٹیسٹنگ کے اوپر کچھ اور بات کرتے ہیں. As you know, white box testing deals with that form of software testing where code or program is available for review and understanding. And software testers look at the code and develop test cases so that they can test the flow of control and flow of data in those programs. So the testers really depend on the availability of software programs or code in order to do white box testing. And so that is the most important and fundamental prerequisite for conducting white box testing, that the code is available and testers and test case designers must take benefit and look at the code and then develop their test cases and perform testing. So before we have a little bit more discussion on white box testing, let's first ask a question about why we actually need white box testing. What is the importance of white box testing? And that question is, why spend time and energy worrying about and testing logical details of a program when we might better expend effort ensuring that requirements have been met? Or we can simply state this question as, why don't we spend all our energies in performing black box tests or performing black box testing activities? So let's try to answer these questions. Number one, logical errors and incorrect assumptions are inversely proportional to the probability that a program path will be executed. That is, it is the logical errors that are present in the program that will force us to force our controls that they will not be exercised when the program is run. Secondly, we often believe that logical path is not likely to be executed, but in fact that path would be executed on a regular basis. And this happens because we don't pay attention to the results of a very complex or even a simple, sometimes a condition statement. And so it is very important for us to actually try to execute all the statements in a program at least once, so that we can be confident that all the statements have been executed and there are no surprises when the program is delivered to the customer. And typographical errors are also randomly available in programs, and it's more likely that they will be available in untested parts of the program. And if we don't have the confidence that all these statements have been tested and executed at least once, we cannot be sure about those typographical errors, and they may suddenly appear in certain circumstances, in certain situations, when the customer is trying to execute the software. And so for us to gain confidence that before the code has been delivered to the customer, all the software paths have been executed at least once. And white box testing uses the control structures of the procedural design to derive those test cases which will exercise all the paths. So we say that black box testing is very important in order for us to test the complete functionality of the software product, but white box testing gives us the confidence that all the statements in the programs and different programs have been exercised at least once, and that all the conditions have been tested for both possible or all possible results. As you know, that there are condition statements that have two answers, and some condition statements have multiple answers, or control can flow in multiple directions. And so this is the white box testing that enables us to gain that confidence which is necessary for from the quality assurance perspective that the development team must have. We were talking about the use of control structures in the program for the development of test cases. And so all the white box testing methodologies or methods derive test cases based on the source code that is given to them. Now these test cases guarantee that all independent paths within a module have been exercised at least once. That is something that I was talking about just previously. And this is very important because if we have executed all statements at least once, we have gained the confidence that we have seen the complete flow of program in all possible scenarios, and the program works as intended. Secondly, the test cases exercise all logical decisions on their true and false sides, and that is whenever we have a condition, a simple condition would have two possible scenarios. Either the condition would be true or the condition would be false, and we have test cases which result in the execution of both sides of the condition statement or the decision statement. The test cases also execute all loops at their boundaries and within their operational bounds. And loops are also a very important part of all programs that are developed, and many algorithms are contained within these loops. So it is very important to perform adequate testing where we have used loops, and loops are used in almost every program that is developed. And test cases using white box testing approaches are developed so that the loops have been tested also. And the test cases also exercise internal data structures and ensure their validity, so that everything that has been declared inside the program or inside different classes have been initialized and used appropriately. So these are the four main areas which are exercised, which are areas of concern when we are developing test cases using white box testing techniques. Now we are going to discuss different white box testing methods. We will spend some time on basis path testing, condition testing, and loop testing, and we will briefly touch data flow testing. So let's begin our discussion on basis path testing and see what this is. Basis path testing is a white box testing technique, and it was first proposed by Tom McCabe. It enables the test designer to derive a logical complexity measure of a procedural design and use this measure as a guide for defining a basis set of execution paths. What this is saying is that for every statement that is contained in the software code, and for us to execute that statement at least once, that statement can become part of different possible paths, different possible execution flows within one execution of the program, because of the condition statements, because of the loops, because of other structures that we have in different programming languages. And so the first thing that we must do is to identify all possible paths within the program that we are testing. And so the first step was to identify different paths within the program, and then we write or develop test cases that will ensure that every statement in the program is executed at least once. That is the foundation of basis path testing. Basis path testing uses cyclomatic complexity, which is a software metric that provides a quantitative measure of the logical complexity of the program. So cyclomatic complexity tells us how complex the software code is. The higher this number, the more complex the software code is, and we would have to have more testing conducted to be sure that every statement has been executed. In fact, cyclomatic complexity, if used in the context of basis path testing method, tells us the value of the maximum number of tests required to execute all statements at least once. So if the cyclomatic complexity of one program is say 10, this would mean that we would require 10 tests, or this would also mean that we have 10 independent paths within that program that require test cases. And so we would have to write tests that utilize those test cases to exercise all the independent paths in that program. We will just in a short while learn how to calculate or how to determine the cyclomatic complexity of a program. But let me just say this again, that when we use cyclomatic complexity of a program in context with basis path testing, it defines the number of independent paths in the basis set of a program and provides us with an upper bound for the number of tests that must be conducted to ensure that all statements have been executed at least once. So the cyclomatic complexity is has at least two benefits. One, it tells us the complexity of the program, but it also tells us that it tells us the upper bound of number of tests that are required, so that we can be sure that all independent paths within that program have been tested. So this is a very important number. There are a number of ways to calculate this this cyclomatic complexity. The independent path, let me say this again, very important concept here, that an independent path is any path through the program that introduces at least one new set of processing statement or a new condition. So we can have, let's say, a program which has initialization, which is typically common in all the paths, and then there are certain conditions. Let's say there's a condition C that is a simple condition and the result is true or false. Here we are developing two paths. So we have initialization and then condition, then we have two paths, and then there may be further conditions down in the program, or if the complexity of the condition statement is such that it results in multiple execution paths, then each one of them can become an independent path. Now let's see how we calculate cyclomatic complexity. On the screen you are seeing a flowchart which has certain action boxes and certain decision boxes and the flow of control. If we carefully look at this flowchart, the number of simple decisions in this are 3, and the cyclomatic complexity, if we want to calculate cyclomatic complexity using a flowchart, it is very simple. You just have to add 1 to the number of simple decisions, or if you carefully look at the flowchart, you can say that the number of enclosed areas plus 1 is also equal to the cyclomatic complexity. Typically, cyclomatic complexity is depicted as V of G, and V a function of G, and in this case you can see that the V of G, or the cyclomatic complexity of this flowchart or program based on this flowchart, is 3 plus 1, which is equal to 4. Cyclomatic complexity can also be calculated by developing what is known as the flow graph or a program graph, which depicts logical control flow in the program. A flow graph primarily consists of edges and nodes, and it has notation for sequences, it has notation for if conditions, it has notation for while conditions, for until statements, and for case statements. And these are different constructs that are typically available in any program. And so we can show this pictorially by developing, we can show a program pictorially by developing a flow graph or a program graph, and we can calculate the cyclomatic complexity using the flow graph also. As you can see on the screen, the flow graph notation here, each circle represents one or more non-branching PDL, program definition language, or source code statements. And you can see that the notation for sequence, for if condition, for while conditions, for until, and case statements are shown in this picture. So if we are using the flow graph approach, the cyclomatic complexity is calculated as edges minus nodes plus 2. So V of G is, or cyclomatic complexity, is equal to edges minus nodes plus the number 2. And if you take any program and you use the flowchart to calculate cyclomatic complexity, or you use flow graph to calculate cyclomatic complexity, you will obviously come up with the same number, because that is the cyclomatic complexity of that program. But the condition is that the flow chart and the flow graph have to be equivalent. That is very important. Let's now talk about the steps that are taken or necessary in the basis paths testing approach to derive test cases. The first is that using the design or code as a foundation, we need to draw a corresponding flow graph. So we can either use a data flow diagram, or we can use a piece of code or even design as a foundation, as a first step to draw the flow graph. And the second would be then to determine the cyclomatic complexity of the resultant flow graph that we had developed in the first step. This is the magic number. This tells us the number of test cases, a number of independent paths within that program. And higher the number, the obviously more independent paths there would be. And on the other side of it, it will also tell us how complex your program is. And so if this is a very high number, that may be an indication that you would want to look at the design or code and try to simplify some of the things. The third step is to determine the basis set of linearly independent paths. Once you have the cyclomatic complexity of a program or a function, you need to identify which statements form an independent path, and I'll show you a picture that just does just that. And the fourth and the final step, obviously, is to prepare test cases that will force the execution of each path in that basis set. So this number, that cyclomatic complexity number, helps us in reaching or determining the upper bound that will tell us that we need to have so many test cases or so many independent paths within a program that will enable us to test all statements at least once. Certainly certain statements like initialization statements will be executed several times, but all the statements will be executed at least once if we follow the basis path testing and we utilize cyclomatic complexity number. But this then does not help us in actually developing the test cases. The test cases would then have to be developed by the testers and test case designers by looking at the code, because that's really the basis of white box testing. So here again you have data flow diagram, and you have these action boxes and you have decision boxes. And since we know that the cyclomatic complexity of this particular program, it's a very simple program, is 4, and it is 4 because there are 3 simple decisions in it, and we add 1 to it and we get the cyclomatic complexity as 4. So there are at least 4 independent paths that we need to find. So we have numbered the different statements or blocks of statements. So path 1 could be 1, statement number 1, statement number 2, then we have statement number 3, 6, 7 and 8. Path 2 is 1, 2, 3, 5, 7 and 8. Path 3 is 1, 2, 4, 1, 2, 4, 7 and 8. And path number 4 is 1, 2, 4, 7, 2, 4, and then it goes on, and 7 and 8. So you can see that in each of the paths there is at least one statement or one condition which makes it unique and independent from other paths. So that is the key. And if we develop test cases based on this information that we need to test all of these 4 independent paths, then we can be confident that we have exercised every statement, that we have executed every statement at least once. If we don't do that, then certainly we don't have any clue, any mathematical clue, or we don't have any confidence that we have determined, we have exercised all statements at least once. So the importance that you have, that you see of basis path testing, is that it gives us a quantitative number, it gives us a discrete number that helps us in, first of all, identifying the number of independent paths, and once we then actually find those paths within our code to determine the test cases. So this is a very good testing technique, and it gives us a lot of confidence that if we derive our test cases based on basis path testing, we can have a lot of confidence that before we end our white box testing, or before we deliver our program or software project to the customer, we have confidence that we have exercised all statements in the software product at least once, and there are no surprises that some of the code is contained within the product is dead code. Dead code is such code that is never executed. So this was our discussion on basis path testing. Let us now talk about conditions testing. Conditions are very important, or logical statements or decision statements are a very important part of any software program or source code. There are hardly any programs which don't contain conditions. Conditions can be simple conditions, they can be relational expressions, and they can be compound conditions. And we had seen some of those simple conditions before, and we will talk about others also today. Conditions actually make our programs very interesting. If we have just simple sequential steps, then the programs are not very interesting, because they will have a very simple, straightforward logic, and no complexity will be handled in those programs. But as you know, that software is increasingly solving very complex problems of this world, and so by nature, the complexity of logical decision making would be included in the software programs. And it is interesting that errors are much more common in the neighborhood of logical conditions than they are in the locus of sequential processing statements, because here we have the opportunity or the possibility of making mistakes, because when we are running, as we are running simple, straightforward, sequential statements one after the other, the possibility of making errors or possibility of introducing errors is minimal. But when we have conditions, and they can be simple conditions or complex conditions, the possibility of making a mistake or introducing an error or injecting a defect increases manifold. And the testing condition methods focus on testing each condition in the program. So first we had talked about basis path testing, where we would try to identify all paths in the program. Second, we have this condition testing, where the focus now shifts from independent paths to inside those paths, and to look at each condition, that may be a simple condition or a very complex condition. And if we have complex conditions which are actually amalgamation of simple conditions, then we have to try and test each of the simple conditions contained within that compound or complex conditions. So condition testing is also very important part of white box testing techniques. If a condition is incorrect, then at least one component of the condition is incorrect. Therefore, the types of errors in a condition can include Boolean operator error, a Boolean variable error, a relational operator error, or arithmetic expression error. So these are the possible errors that can result if the condition is incorrect. So one of these things, one of these errors will result if the condition is not correct. And so when we are designing conditions, there's another aspect to condition testing, is that whenever we have a condition, the path of the program changes. Either the program is going to follow the path which results when the condition is true, or if the condition is false. There is another aspect to it, that the condition is incorrect, and the condition testing is focused primarily on that area. So the purpose is to detect errors in the conditions of a program, but as a result we will also find other errors. And if we focus our attention on conditions, we will be able to find many hidden errors also, because that's an area in the program where you can find other defects also. So initializations done before conditions and after conditions, this is an example where you need to be very careful. Just like when we are testing loops, the initializations done before the loop and after the loop has started would mean two different things and would drastically change the algorithm. And so is the case with when we have conditions in a program. Primarily, there are two advantages of techniques that are based on this concept of condition testing. Number one, the measurement of the test coverage of a condition is simple. That if we are trying to measure the test coverage, so this condition testing makes it easier, because we are now focused on testing. We are now focused on testing conditions. And as I said, that conditions have these two outcomes, true or false, and we need to cover both of these areas. Secondly, the test coverage of conditions in a program provide guidance for the generation of additional tests for the program. So whenever we have worried about coverage, we also, when we are focused on testing coverages, we are also focused on, we will be guided to write additional test cases related to that area of the program. So just by focusing on conditions, we can improve our software testing activity. There are a number of condition test strategies. We don't have time to go into the details, but we'll just mention that we have branch testing, Branch testing is typically the most simple form of condition testing. Let's say that for any compound condition C, the true and the false branches of C and every simple condition contained in C need to be executed at least once. And that is the simplest form of condition testing, and that is what we have been talking about up till this point. The second is domain testing, and this is related to the relational operators and how the relational operators impact, what is the impact of, what is the proper usage of relational operators, and would some of the relational operators make sense in certain domains, and also the level of the precedence, which operator comes, or which operand comes before another operand. All of these issues are related to domains, and specifically, since we are comparing them, they are known as domain testing in condition testing. And the third approach is the mixture of the above two, that is BRO, branch and relational operator testing. And this approach, or this set of approaches, combines the branch testing, which deals with the selection of true or false in a condition, and the domain testing, which is the testing related to relational operators. So these two things are then combined into the BRO. That concludes our discussion on a very important topic, and that is conditions testing. You have to be confident that you have tested almost every condition, specifically all the complex conditions, before you hand over your software to the customer, because your defects in programs typically would be found around these condition statements, and another area which is loops, that we'll talk about a little later today. The third testing strategy that I'm going to briefly mention is data flow testing. This method selects test cases or test paths of programs according to the locations of definition and uses of variables in the program. So this is focused on where the variables are located and used, and where they are defined. And so, as the name indicates, this testing is basically testing the flow of data in the program, and you are really focused on when a variable was defined and where it gets changed and where it gets updated and where it gets deleted. And so that sort of testing is also used for selecting the test paths for programs containing nested if and loop statements. So wherever you have complexity within a program, data flow testing is useful. It is understood that this will not be applied on all in all circumstances, but this can be helpful in complex conditional statements and nested statements and nested loops, where the possibility of there's a possibility that we cannot visualize what the value of the data is, and where the how the values of data elements are changing. So data flow testing technique or data flow testing approach is becomes handy and useful in those situations. Let us now talk about loop testing. Loops are cornerstone of vast majority of all algorithms implemented in software. A combination of software loops and condition statements makes the software worth what it is. If there were no loops and there were no conditions, the software programs honestly will be very boring. And despite the importance of loops, we don't spend much time and effort in testing software that has loops. Complex loop structures are another hiding place for bugs. It's well worth spending time designing tests that fully exercise loop structures. As I had mentioned earlier, conditions are also areas where we find that defects are found. And so coupled with loops, these are the two areas which need special attention of software testers so that they can develop good test cases to test condition statements as well as loops within a software program. As you know, that loop testing is a white box testing technique, and the focus is exclusively on the validity of the loop constructs. There are a number of classes of loops that can be identified. For example, we can have simple loops, we can have concatenated loops, we have nested loops, and finally we have unstructured loops. And any loop testing technique or strategy must need to address all these four types of loops in a program, and we will see the impact of each of these in our discussion today. You can see what these loops means, or what these loop types means. We have simple loop, we have a nested loop, a loop inside a loop, then we have concatenated loops, and then we have those unstructured loops where typically it is not clear from the code that the entry and exits of the loop are not very well defined, and these are the most dangerous kinds of loops and should be avoided as much as possible. Let's talk about simple loops first from testing perspective. One of the things that you need to test while performing loop testing is that the option of skipping the loop entirely. You see, in many scenarios the loops would start with the condition, and if that is the situation, then you should have test cases that skip the loop, that is, the loop is not executed. Then there's a possibility that the loop is executed only once. Then you can have 2 passes through the loop. Then you can have m number of passes through the loop, where m is smaller than n, and n is the number of total passes in that loop. And you must also devise test cases that test the loop n-1 times, n time, and n+1 times. And if you have n+1 times successful in a loop which has only n passes, then certainly there's a problem. And so the idea here is that you should develop test cases to test the loops that are contained in the program thoroughly, because any additional passes or fewer passes than required would certainly result in incorrect execution of the program. And if you carefully look at your source code, you will find that many errors result because of too many or too few passes through a loop construct. Then you have nested loops. When you are testing nested loops, you would typically like to start with the innermost loop, and you set all the outermost loops to their minimum iteration parameter values, so that you can test the internal or the innermost loops first, and then when you have successfully tested the innermost loops, then you go out and test the outer loops. If you have concatenated loops, then you would want to test them independently. That is, you would want to test the first loop and then test the following loop. You must also be careful that there would be dependencies of data values coming between the two concatenated loops. And a word of caution about the nested loops also, that here also you have to be careful about using appropriate and accurate variables in both the inner loops and in the outer loops. So, as we increase the number of loops, the possibility of error increases. Then we have these most dangerous unstructured loops, and I honestly tell you, these are the worst nightmares of software testers. As a quality assurance mechanism, I would suggest that you have a look at the redesign of software that includes these unstructured loops. Typically, they were allowed as go-to statements were used in the earlier days of our computing profession, but as the improvement in language design and structured methodologies, the use of go-to statements is considered harmful. And in fact, if you go back and search through the history of computer science and you go through the literature, a huge debate took place in the among researchers and academics about the use of go-to statements and their dangers associated with go-to statements. And there was another group within the community which thought that go-to statements were a good idea, at least at that time. But in modern computing days, in modern computing profession, the use of go-to is not considered a very useful construct, and so all efforts should be made to eliminate these unstructured loops, because they can really make the life very complex and difficult as far as testing and quality assurance is concerned. And so if you come across unstructured loops, try to make them, simplify them and break them down so that they are either simple loops or nested loops or concatenated loops, and then you can test them accordingly. So in today's lecture we have discussed white box testing techniques in quite a bit of detail. We had our attention focused on basis path testing, conditions testing and loop testing, and we briefly mentioned the importance of data flow testing also. And so white box testing is an important part of overall testing strategy for any software product that is to be delivered to any customer, whether it's the internal customer or an external customer. And we should utilize white box testing to the maximum benefit so that we remove all possible defects that can be removed using testing. In the next lecture we'll talk about black box testing techniques, and we'll take on the discussion from then. Till then, Allah Hafiz.